So who in here really understands how your browser calculates style?
Nobody.
All right, the person who raised their hand should come up here and give the presentation, because they are the only one. The answer is nobody. Up until recently, I would have said, sure, like I read the spec, I kind of know what we do. And the answer is I had no idea what we do. The system is ridiculously complicated. People are like, oh, there's CSS and divs and stuff, and like stuff shows up on your screen. And that's about how well we understood what actually happened to. So we're going to play a game like The Price is Right. How expensive is that? You have a div on your screen. It's already displayed. It's Gmail. Gmail appends 100 conversations, like those one little line things in the page. How many times do you think we look at each of those before we put it on your screen? And I'm not even talking about painting, because that does it another like X number of times. Yeah. 500? Yeah, if there's 500 of them, if it's 500 to be linear, the answer is no, it's not. It's 2n and then 2n squared until 6 months ago it was. We fixed 1n squared, and Levi has a patch that's like trucking its way through the commit queue and will kill the other one, assuming we can land it. Levi's landing it right now. Commit. So yeah, that's about how much time it took. And people are like, man, your recalc style is really slow. And, that's why it's really slow. It was pretty sad when we realized this. This all came out of the lazy block demo. We created this page that was an infinite scroll list, and we were like, why is this slow? Is it because of layout? Is it because of these other things? And we were like, no, it's because our algorithm is just ridiculous. So to begin to understand what's actually going on, I'm going to explain the forest, because your DOM is not so much a tree anymore, and that changes all kinds of things, and it turns out that we should leverage this all the time. So everything should start at the document. More and more algorithms I find in our code base try to be really smart, and they like, oh, I'm at this element, and I think this element's the only one that changed, and so I'm gonna like walk up the tree and around at my siblings, and I'll make some decisions, and it'll be great. No, start at the document, mark some dirty bits, walk the whole tree. It turns out those algorithms work great. They are like always correct. These are the ones that work really well. And in our new tree, we have an element, and this element is awesome because it has a tree of trees, which we call element shadow. And off of that, it has shadow roots, n of them. And each of those has more elements. So your DOM is 3 dimensions. Not only is it a tree, it's like a 3-dimensional tree. Someone on a team of ours made a cool 3-dimensional viewer for this thing. It was kind of neat. But this is what your DOM actually looks like now, and this is super important because when we consider recalc style, it actually walks the tree in that order. It turns out this is not super well understood because there's all kinds of code that didn't get it, that in fact thought that we'd look at your children before we looked at the shadow roots. And that's not the case at all. So we actually start the document, we come down to your element, and then we go across, and we look at all these tree of trees, and then we get to your children eventually. And for extra fun, this stuff over here can run stuff that actually pokes stuff over there. So what does recalculate style actually do? Well, it always starts the document as of recently. And that's super important because it adds sanity to the whole system. It also walks this forest. I'm going to use that term a lot because I don't really know what walking a 3-dimensional tree looks like. No one's like really spec'd reasonable like breadth first traversal across a 3-dimensional space. So that's what this thing does. And it creates the render tree. And occasionally recreates the render tree. And it also has this other awesome step about white space. The hardest part of recalculating style until recently was creating white space. Everyone in the room should go, what? White space, yes. Yes, we spent weeks trying to understand white space. And that's because it turns out your page is covered in little white space nodes everywhere between basically everything. And so someone came up with this great idea where we wouldn't create those renderers. It's a great memory optimization, right? Except it put n-squared stuff and buggy stuff everywhere. And this was like 7 years ago. It was like, I traced it back to 3-digit commits in WebKit was when this optimization was added. So we've had that n-squared thing for equally as long, which is awesome. So what kind of recalculate styles are there? This wasn't super well understood until recently either. There's a bunch of enums. They all had confusing names. I renamed them when I understood what they actually did. So yes, if you see an enum and it doesn't make sense, please rename it. We will rubber stamp your patch. Even if the names are not perfect, like just rename them all. Give them long, really long sentence-wide names, like this is what this enum does, or add some comments. Great. So the local one says my style changed. That's just myself. That's like poking inline style and stuff. Then there's this subtree style change. That's my style and everybody below me. And then there's this lazy attached style change that I added recently, which basically says, I'm new to the tree. I'm sort of display none, but actually that's a lie because you've never computed my style. And what we do is we go down to those elements and we create their renderers on the next recalc style. And that's what those enums mean. If you see them and use them, that's what you should use. In practice, most people should use the local one. I went around the code base and fixed a bunch of this. Like animations had this awesome feature where if you animated the border width of an element, we recomputed the style of all the descendants, which didn't make any sense because your border has nothing to do with your descendants. But that's because these were not well understood, what these enums actually meant. Then there's this concept of what changed in a recalculate style. So there's no inherit concept, that's like borders. There's this inherit concept, which is things like color. Then there's this concept of force. Force says, I actually don't understand what changed, and I just want to compute everybody's style all over again. This one is super sad. This is one that we should all strive to replace. If you want to work on style, we should work on getting rid of that one. We use it for things like selector changes. If the hover pseudo class starts matching, we go and we just compute everybody's style sort of in that tree because we don't really understand what changed down there, and so we just blow the whole thing away. And then there's this reattach, which is like, it's too hard to fix the render tree, so we're just going to destroy it and recreate it. And that turns out to actually not happen too often. It's when we first build the render tree and when you mess with display. We have awesome bugs where if you reattach an element, we restart plugins. So in practice, developers got weary of messing with display dynamically because no one likes when their YouTube player like restarts in the middle. So I wish I had like a gold clock on my neck for this one, like for so much cash. Anybody know, like T-Pain maybe? Computing style is just all about caches. At some point, we decided that computing style was slow, so we put, more money, more problems. How many caches do we have in this diagram? And the answer is lots of them, and I'm sure I didn't depict all of them correctly. We have an LRU cache as of like a week ago. It used to be walk the tree and make a bunch of complicated decisions cache. And then we have a property cache, which says building a render style is slow, so we'll save that information. We have an attribute cache, which says figuring out the style from your attributes, like border is slow, so let's put a layer of cache on top of that. There's ones about figuring out which rules to match. There's a bloom filter. And what's awesome is a bunch of these have random timers. Did you know if your style stops touching, if your page stops touching style for 60 seconds, that this style resolver evaporates on you and your next style resolve takes forever? Yeah, we found that one too. It's awesome. It turns out that most pages poke the page like just enough that they don't notice. But if you leave your Gmail tab sort of chugging away in a background tab and like nothing happens for a while, you'll go back and it like locks up for a second, and that's because we just processed Gmail's like 5 megabytes of CSS like all over again for speed. So in the general case, we have this system called style sharing, which says find styles that you can just use without actually matching any of the CSS rules. In practice, I think we saw this, which like 30% of style? Less than that. 15. Oh, this is even worse. All right. So it's 15%. It's even better we switch to an LRU and ditch the super complicated thing because it's 15%. But it's cool because in practice, you'll have like a bunch of things next to each other that all use the same style. And so we look at your siblings and your parents. Gmail likes to do things like have 10 nested divs that are all identical because why wouldn't you do that? And then we have all these other layers of caches. The presentational cache is another awesome timer-based one, except for fun, not only is it based on a timer, it's also based on the last access time that I poked it. So if I continue poking it, it sticks around a little bit longer, and then eventually it goes, nah, I'm done. And it just evaporates on you. And it's even more awesome because it's tied in with another cache, which is only open for 60 seconds during page load. Did you know attributes are shared for 60 seconds while the page is loading? Yeah, inner HTML right at the beginning of your page is really, really fast. Memory usage is awesome. After 60 seconds, inner HTML expensive and uses way more memory. So clearly you should inner HTML everything right when the page loads, and screw the user. Don't worry about that. Yes, okay, someone in the back. So we have this awesome thing called a bloom filter. Does everyone know what a bloom filter is? Hopefully the answer is no. Okay. Bloom filters are these crazy things. I love data structures. I don't get to build fancy ones too often, except for the crazy tree of trees things we've got going on. Bloom filter is a hash set that can answer only one question, which is maybe I gotcha. And if it says no, then you know for certain it's not there. But if it says yes, you have no idea. Sure, it might not. So we use this as we walk down the tree, but we only use it for three things. So it's IDs, classes, and tag names. Anything else, and we bail on it. So if you use something fancy like a hover that's not qualified, you get the slow path. This is also not super well documented. It just happens that people use these things all the time. But the idea is when I'm computing the style of an element, I consult the bloom filter and I say, this rule has a div in it. Do any of my ancestors are a div? And if it says yes, the answer is actually maybe. And so then we walk all your ancestors and figure out if it's true. But if it says no, then we know that it didn't match. We fiddled with this recently and messed around with the amount of information we stored in the bloom filter, and it was what, like a 7% regression on New York Times? So it turns out that most of the time this is super effective. It means that we skip most rules as we go down the tree. And the bloom filter is actually pretty small. I think we only keep 4 chunks of rules. It just so happens that's enough for most people's pages. This is my SVG flower to represent a bloom. It was surprisingly hard to get good SVG art out of Google image search. Someone who works on SVG should get on that. The next step is this attach and detach concept. The word attach means nothing. The word detach means less. Yeah, so these are the two processes for creating the render tree and destroying the render tree. I think at one point they were like 2 separate things, and there's this like linking process in the middle, and maybe the word attach kind of made sense. I think Mozilla actually has a hash map that keeps things together, and maybe then the word attach sort of makes sense. I don't know. This walks the forest. Same order, same algorithm. Walks across your shadow roots and then down to your descendants. Previously, the parser used to do this, which was awesome. It meant that while the parser was running, it was spitting out renderers. And then it would run into a style block in your page, as almost every page ever has one in the middle of it, because that's awesome. And then we would go and destroy all the renderers and start over from scratch. Wikipedia is notorious for this. Turns out basically every other page I looked at is too, because all of them, for some reason, someone developer is like, my application is too complicated because I don't have web components. And so I put a style block in the middle of the page that only like pokes at this one thing. And there's this fast path that says if you only use IDs and class names, we won't blow away the whole render tree. And that seemed reasonable, except the developer doesn't know that because we didn't tell anybody. And so they add something simple like a hover selector or something, and all of a sudden their page goes tanks. And there's a lot of that. And then there's this attached method. I'm going to get to that later. We should figure out what it actually means, because I don't think we actually know. So this is what creating the render tree looked like recently. Still vaguely like this, but a little bit better. And when Levi's patch lands, it'll be awesome. So this is 2n squared, because I have an element, and the first step says find my next rendered sibling. But all of them are not visible yet, because Gmail added 500 of them. So we're going to walk all the way to the end of them. This returns null. That's great. Then we do this insert after operation, which shoves it in. And then we're going to walk all of the siblings again just to figure out white space. Which is great because Gmail has no white space because their templates don't contain text nodes. And also, this walking to the end is silly because all of them are display none because we just added them. This sucks. So what we did is we took this loop here and we smashed it up into the upper loop. And then we took this next rendered sibling, which is walking one way across the tree, and applied some dynamic programming fun, and took the loop up top and switched it. So now Recalculate style starts the last child and walks towards the beginning. And that means that when you go to your next sibling, it already had its style recalculated and it has a renderer. And by making that, both the n-squareds can go away, and the awesomeness is achieved, where we took our lazy block benchmark. I think it spent like over a second. It was like huge amounts of time inside of these loops, which was awesome because one, again, there was no white space at all in this page. And also because any real page that does infinite scrolling is doing just this. They drop 50 elements into the page while you're scrolling to try to pad out the prepaint buffer, and we would n-squared walk them in both of these loops, which was not super great. So what does attached actually mean? This is a really good question. Lots of code says if attached, do something different. And it turns out that none of the code really knows what it means, because in every place it means something different. It sort of vaguely means I'm in the tree. The style system kind of knows of my presence. I sent it a letter. It may not have opened it yet. Not awesome. So this is a concept that we need to remove. And if you're writing new code, I would compel you to not call this method. In fact, we should rename it something like deprecated, confusing, doesn't really mean what you think it does, attached. It sort of, you probably want in document. Almost everyone wants in document. Maybe you want my document also has a frame. Those might be the two checks you want. You barely want this thing. And this thing was added long ago when the tree was confused and didn't really know what was going on. Now, if you are in the tree, you are attached, always. It is always true, unless you're in the middle of being reattached. But it's always true. In fact, a lot of bugs I fixed recently were nodes would be left behind, not attached. And the style system was like, I have no idea what's up with you, so I'm just going to leave you alone, and you'll be display none forever, which was sad. So we're going to get rid of this. And then, for awesomeness, we're going to look at smashing the concept of attached directly into the tree in that first loop when you insert the child, which removes the 2 in front of that number back at the beginning of my presentation, which would make it n, which would be great. Because right now, we walk it 1 extra time for good measure, just to be sure that it really does have a renderer. If anyone wants to work on this, that would be awesome, because it turns out each of these patches fixes some 10-year-old bug and performance goes up. In fact, through the saga of making things lazy attached, we fixed a just ton of old bugs that were like 10 years old. And not only was that awesome, but at the end, the performance increase was like huge. So a lot of these things are like, oh man, this code's kind of old and crufty. But it turns out if you like spend the effort to like make sense of like each little piece of it, like the wins that we get back are huge, because at the end there's this like clairvoyance and you're like, oh man, the system does sort of make sense. So the next thing is there's this framework for how do I build an element. It turns out that these are not documented, no one really knows what's going on here. Every element does it differently. And as we add more cool widgets to the platform, it becomes increasingly important to understand these. There's these Recalculate style hooks. In the web platform, if you're writing JavaScript, you don't get any of this fun. And it turns out that was great, because you couldn't do anything bad. And in C++ land, you can do everything bad, so we gave you all the hooks. So it's our responsibility to use them wisely. There's before and after Recalculate style that almost does what you think they do, but doesn't, because we call them as you walk down the tree, which means there's lots of code that as you go down the tree is doing a bunch of random stuff because your children had their style recalculated. So that was fun to find. And then there's this custom style for renderer. Almost everybody who's doing fun stuff probably wants to implement one of these. And this says, I would like to customize my style. There's lots of code kind of all over the place that does this, and we've slowly been migrating towards it. But that's the one that everybody really wants. And it says, I don't want to poke the inline style like JavaScript would, but I really just want to customize my style. And that's what most new elements probably should use. And then we have these attached and detached hooks. And it turns out because we didn't really understand when they ran, because they ran inside the parser, they ran occasionally when I touched a form control, they ran when a user clicked on a select box, and they also ran in Recalc style, that none of them really know what's going on. So that's probably not what you want, but they're there just in case. We found recently that SVG is using the hooks that insert into the DOM to make all these decisions instead of attach and detach. So it's actually like when you mutate the DOM, SVG is making all kinds of decisions about the way it should look. So as you like move elements back and forth in SVG, we do way more work than necessary because we assume that this like change happened immediately, when really we should defer all the work like we do, which would be great. So then, now that we understand this system, and everyone in this room can go work on this project, and we can like post slides, and everyone will be like, super excited about it, what are we going to do? So the first thing is performance. We're going to fix both n squareds, which Levi's typing away super fast about, and there's probably more of these to fix that we should make this platform really fast. The next thing I think is smarter caches. We have 7 layers of cache when you go to get your style, and it turns out lots of them are not super well understood. Like the shared style thing is like 15% and of elements share their style, which is a lot lower than we thought. And then the Bloom filter turned out, a lot of pages looked at it, didn't matter, but then on some pages it was huge. So there's some trade-offs to be made, but really we should look at just generally smarter caches. In particular, if you touch the inline style of an element, which developers do all the time, like div style border equals, we blow away the style, rematch all the CSS rules, and then put the style back on top of it. Which means that if in a ref loop you just do nothing but reassign the same value over and over again to the same property, we will destroy the style, recompute it, and match all your CSS all over again for fun and profit. So these are all kinds of bugs that need fixing. This is why people think it is slow. This system needs lots of love in that area. That's smarter updates too. It turns out lots of things that you touch cause way more catastrophic, like reaching changes. Recently, we came up with this crazy idea about jitting selector matching. Long ago, someone said, what if we jitted regular expressions? And then we did, and it was crazy fast. And I think we just want to do the same thing. The selector matching is this relatively simple concept. You like has a couple of predefined operations, walk up the tree, across the tree, down the tree, those kinds of things. And if we spit out the correct assembly for them, even if it's in like a virtual selector matching machine, we can produce super fast code for them, which would be great. In theory, we could also run it on another thread. To piggyback off Philip, we want to partially recalculate your style. Pages love to do things like grab the style while the page is loading. And we compute the style, build the render tree, and then they do something great like adjust the font size on the body, which is not awesome. So instead, we think we'll recalculate the style partially. If you ask for some element, we'll compute up to that element, maybe only its ancestors, give you the answer, and then stop. And that'll be great because there's really no reason to build the render tree until you ask for the size of something or we try to paint. And that would be nice. The other thing is, which is also computing the style without renderers. That's a prerequisite for this. The fun one that came out of LazyBlock is computing self-contained blocks. This is a super cool project if anyone wants to participate. The idea is as you're computing style, you can keep track of which sections of the page are completely self-contained. That is, contains no negative margins, other crazy CSS stuff. Given those pieces of information, you can just not do layout on them because you know they can't be visible based on things like the size of the viewport. One of the questions yesterday was, how do I know that that painting stuff below the fold is safe to skip because it's not visible? And the answer is with math, because if your negative margin is 5 pixels and this thing is already 10 pixels below the bottom of the page, then the negative margin cannot possibly pull it back into view. And you can apply a bunch of rules like that. Tab is going to tell me I'm wrong. All right. Woo! Everyone should clap because the web is going to be super fast. All right. So we're also going to add Overflow Clip. I don't think I have it listed up here. But the idea is you put this on your div and it says, I don't care if you have overflow or you do something crazy like transform your children out, but we will just clip them off. And this is great because when your page first loads, we'll chop off the stuff off the bottom that we know isn't visible. And we can skip it for layout. We can skip it for recalculate style once we hit the top of it if we know that it's super far down. There's like lots of things we can do. That's super exciting. Particularly, I'm excited about sprinkling this all over the HTML spec and getting the HTML spec to load like instantly on your computer. We also, I think we should thread CSS parsing. It turns out it's 3% of just about every profile ever is parsing CSS. And it's somewhat silly because Gmail, for instance, has 5 megabytes of CSS on mobile, I think, in the head, which is cool. And so what happens is we hit that block of the style element, and we parse the CSS immediately, right then. And the HTML parser is just sort of stopped. Now, the tokenizer is running on another thread, which is great, but it stops building the DOM and doing anything while the CSS trends away. But that's actually kind of silly because we're not going to recalculate style until the next paint. So it was kind of useless. Moving this to another thread would be great. We can do it actually kind of slowly on a background thread while the parser turns away and builds the DOM. And I think that would be a huge performance win if someone wants to do that. I'm told that we could ditch yak. I think we're using yak. What is bison? Okay. Is it actually a yak shave if you remove yak from the code base? But that's, I think, a super exciting project if someone wants to do it. It would be like really easy to do sort of behind a flag. And I think it would have a huge impact. It'd be probably at least 3% on basically every page in existence that uses an inline style that's like of non-trivial size. Yes. Tab is selling his personally written CSS parsing spec that instead of using a grammar is imperative, and I think also written in JavaScript. Okay, so we could also just parse our CSS in V8 on a worker, serialize it to JSON, and send it back to the main thread. Who has hands is a great idea. So to wrap up, what I learned was building the render tree and computing style are super complicated, but are actually fairly well factored into these sort of like small units. But I also learned that algorithms like this that start at the root of the tree are full of correctness, which is awesome. While all the algorithms that I found elsewhere in the code base that like to sort of like walk around locally are not. And so one of the things I did in this process was rewrite shadow DOM distribution to start at the root and walk down the tree and fixed all kinds of bugs. And I'd really like to see us go that same route. So for instance, we're talking about frame loading downstairs right before this presentation. Loading images, instead of doing that inside of Detached, we should just do it right before the recalc style. We should walk the tree, we should load the resources, we should move all that code out, and we should build a system of phases that walks the tree. Because it turns out that walking the tree is not that expensive, but all the like crazy algorithms that we build seem like they're like a little bit faster, except they're almost invariably all end up n squared because the user touches everything, which we have a bunch of cases of. Like you touch every layer in the page and we go and we touched all of them. When we could have just started from the beginning and walked the whole page, we just do this craziness. And the other thing that I learned was that shared timer is a plague of our code base. Any timer that has a non-zero time is also probably a mistake. These timed caches are crazy, and so I think we should reevaluate all of those, and I think that we should work towards building smart caching systems. Like it's never reasonable for your page to say, it's been 60 seconds, I'm going to throw away a bunch of stuff because I assume you're not using it anymore. Like we should strive to build intelligent caching systems that make intelligent decisions. That's what I had to say about Recalculate style. Hopefully there's some questions or some excitement about working on it. Everyone is blown away by how ridiculously awesome our style engine was. Sean. The question was, what do I defer and when do we defer it until? So for one thing, we should defer Css parsing. There's no reason to parse the text node when it's inserted, and we do that right now, which is actually, they added some special cases. I don't know if we did, they did in WebKit, where it's like, if the text node is empty, don't parse it like it's CSS. And then as soon as it becomes non-empty, parse it like it's CSS. Because a lot of pages will append child a style element and then inner HTML the CSS into it. And previously that caused 2 recalculate styles, which is great. And before that, recently, it actually just append childing a style element caused a recalculate style immediately. So as the parser was running, if you had 5 style blocks, you'd get 5 recalculate styles all at the same time, which was also awesome. So I think we should defer more and more work into separate phases. One of those would be like CSS parsing. Another one should be compositor updating. Right now, if in a for loop you touch offset left to figure out the left position of an element, and you do it for 1,000 elements, and for each one you move it, Philip's thing will do this awesome thing where it does partial layout, and like only does a little bit of layout, but the recalculate style will still update the composited layers of all of them in every single one of those offset left calls, which is silly because you can't actually get to the compositor state from JavaScript, and we're not attempting to paint. We're just trying to give JavaScript a number back. And so basically, we should be breaking up the system into these phases and then making decisions. Like compositor update happens at paint time. It's a separate step. CSS parsing happens at recalculate style time. It's a separate step.
In fact, that's kind of why I asked the bigger picture. I suppose it sounds like it's not quite an issue yet, maybe not for a while. But what I'm worried about is, like you said, and I think it's appropriate that we should defer to the compositing requirements, and that should be controlled by the compositor who has knowledge of when it wants to schedule the session. And what I'm worried about is that we might get to a point where we defer everything to the point where there's kind of a feedback from the compositor saying, okay, I need to compute compositing requirements, and then that says, okay, so I need to compute style and layout, and that, there would be some sort of chain backwards, and that would probably make it very difficult for the compositor to actually intelligently schedule things in the first place. And we might need to visit how we defer things in a schedule-friendly way.
I would hope that we would defer things in a state machine way. I don't think deferring things with timers is the future. We have a tendency to defer things with set timeout 0. Like shared timer 0 is effectively set timeout 0. And that's not an intelligent way of deferring things. Like we should be going through phases. Like the compositor should say, I want to synchronize up until the compositor state is consistent. And it'll go through all phases to get to there. And in most pages, if they've touched through JavaScript, like the layout might be up to date, but the compositor state might not be or something like that. And so we'll jump to the next phase and then you'll get the right answer. Yeah. I would hope that we don't have a system where you ask for an answer and then we like backtrack through the steps. I would hope that you just move forward through the state machine. Yeah. Anybody else have any questions, fun ideas? Yes, Glenn. Glenn just told us that when I assign CSS that's invalid, that it should throw a syntax exception. I think we should fix that. It should be asynchronous. Like anything like this, we should probably, like, we can add an on-error event to whatever the thing is, and we can fire it and asynchronously give you an error message. But it's silly to run the CSS parser synchronously, or even on the same thread, because it's like this simple tokenizer. Anybody else? All right, well, thank you. I hope you're super excited about working on style, and I hope that the next custom element that you build, which it seems like we have a proliferation of them, like dialogue and everything else, which is awesome, we'll use the hooks, and then when you see all these enums, you'll be like, oh, I remember that thing actually makes sense to me now. Thank you.